Okay, this is math 2, and we're going to do 51, 54, and 62 and 65. Now, the reason I picked 51, it was not because it was a difficult question, but the actual words, actually verbiage of how they're asking the question was kind of weird. It's a little different than what I asked you guys to do in class today. So it says for the rectangle below, what is the area of each part and what is the area of the whole? Basically, use your intuition with this. It's just like you've been doing in class. You're just going to multiply to actually get the numbers inside the box. So in this case, it would be, let's see, 77, was this 56? I hope that's right. 33 and 24. Actually, I can't remember what 7 times 8 is, but I'm pretty sure it's 56. Let's see, what else do we need to do? Oh, okay, 3x times 11x is going to be 33x squared. That's going to be negative 44x. It's going to be negative 6x, and that's going to be positive 8. Okay, now, what's really asking you to do is give the area as the sum, and that's pretty much it. So that's kind of all what it's asking you to do. What is the area of each part? What it means basically is what's the area of each of the individual squares. So for example, if you had a rectangle that was 7 by 11, the area inside would be 77. If you had an area that was negative 2 by negative 4, which I know a side length of negative 2, negative 4, which doesn't really make any sense distance-wise, can't have negative side lengths of anything. But in the math world, we're on the theory part of it right now. So, yeah, so basically give me the area as the sum, even though it doesn't really ask, it does ask for the area as a sum, because it wants the area of the whole thing. That's the area of the sum. Area of the whole is area of the sum. And then I want the area as the product. Okay, so for both, A and B. Okay, that was 51. 54 is the hard one. Now, it really just depends on where you left off last year, number 54 and number 65. They're kind of about the same when it comes to concept. They were both back in chapter 8. So I'm going to take this a little bit slower. I'm right out of time with 54, so I might just go into 65 and then forget 62 altogether. So we'll see how much time I have. Okay, so it says, read the math notes box in this lesson and then answer the following question. Cost of a large flat screen television is decreasing by 20% per year. What is the multiplier? If a 50-inch flat now costs $1,200, what will it cost in 3 years? Using the same rate, what did it cost 2 years ago? Write an equation to model the function. So what I'm going to do is I'm going to do this as a table first, but we got to talk about the multiplier. So if it's decreasing by 20%, technically when we decrease percentages, we find the multiplier by subtracting from 100. So in this case, since the decrease was 20%, I would take 100%, I would subtract 20%, and then that would give us basically 80%. So this is going to be our multiplier. If we were to increase by 20%, instead of decreasing, then we would add it to 100%, so our multiplier would be 120%. But since we are decreasing, our multiplier is going to be 80%. So in a table, this would look like the following. You have a starting value, 1, 2, 3, okay? It said, what will it cost in 3 years? So right now, if the flat screen costs $1,200, okay, then in order to get to the next number, since this is not a linear function, this is actually going to be something different than a linear function, we are going to multiply by 0.8. That is 80%, right? 0.8. If you want to put a 0, we can put a 0 there if you want to. 0.08. 0.80. Oh my goodness, that's so silly. So you would just basically keep multiplying this. Take this amount, whatever you find here, multiply it by 0.8. Take this amount, multiply it by 0.8, and so on and so forth. Okay, now to go backwards, it wants to know, so that's what it's going to cost in 3 years, right? So this is your years. This is the cost. Sorry, I didn't label that. Now, 2 years ago was technically -1 was 1 year ago, and -2 was 2 years ago. So you have to go backwards. So that means you're going to take 1,200 and you're going to divide it. 1,200 divided by 0.8. And that should give you 1,500 for a year, right? And then you're going to divide that again by 0.8. Because we want to go backwards. So that means it would have cost $18.75. Okay, so going backwards, you're going to divide. Going forwards or going down, you're going to multiply. It says write an equation of a function to model the situation. Since this is multiplication to get to the next number, our function is going to be an exponential function. And it's going to be in the form of y equals a times b to the x power. Okay? Or if you want, we can put parentheses around the b, whichever you prefer. The a is going to come from your initial value. So how much did the TV cost? So in order to find the a value, you're going to look at the 0. So basically you're looking for the y-intercept. That's what this is. So your starting value. And b is going to be your multiplier. Okay, so to put this all together in a wonderful equation, we get y equals, let's see, starting value was 1,200.
Hey Hawks, volleyball tryouts are Wednesday through Friday, August 12th. JV is 3:30 to 5:30, varsity is 5:30 to 7:30. There will be a boys soccer meeting this Wednesday at lunch in Mr. Fisher's room 501. All boys interested in playing JV and varsity soccer should attend. College and Career Counselor. Come see Dr. Chavez, your new district counselor for college and career. Her office is located in the library, room 144. Career Center hours are Thursday to Friday, 7:30 to 4 p.m., and every other Wednesday. Thanks, Hawks. That's it. Have a great day.
Okay, I wasn't saying anything back then. It was just silent because the PA system was on. Okay, so we're going to go to 65. So the band's peak of popularity, a signed black diamond poster sold for $500. So at the popularity level, let's say peak of popularity was at 0. Why not? We'll go with that. It was at $500, and then 3 years later, the band was almost forgotten. And say 1, 2, 3. The poster was only worth $10. Okay, so the question is, because what's the annual rate of depreciation? It's pretty much like number 54. You have to multiply by something less than 1, but greater than 0, so it's going to be a decimal of some sort. Figure out what do you need to multiply by in order to get 10 at the end. Now, there's a fast way to do this, and then there's a short way to do this. I'm sorry, I lied. There's a fast way and a long way. The long way is you can sit here and do this, try to do this 3 times to figure out what it is. The quicker way is to actually use a square root. Now, I need a calculator. Hold on. Okay, I lied. It's not the square root. It's actually the whatever root it is of how many times we're going. So here's what we figured out last year in Math 1. So you're going to take 10 and 500. You're going to divide it. 10 divided by 500. And you get, so we get 10 divided by 500. We get 0.02. Now, since we're doing this 3 times, so we 1 here, 2 here, 3 here, we're going to take the third root of 0.02, and that should give us the multiplier. So if you don't know how to do that on the regular calculator, I'm going to show you on this one, because this is the one you're going to pretty much use in class. So you're going to punch in a 3 on the calculator, and then you're going to, I'm going to zoom out real quick. You're going to punch in a 3, and then you're going to press second button and activate the second, and then you're going to press the one that looks like a roof. It's actually just the caret key. And it looks like that. And then you're going to put 0.02, and then you're going to press enter, and our multiplier is 0.27, and then we can actually check that. So let's just say, for the sake of argument, that our answer is 0.27. And we're going to check to see how accurate that was. So we're going to multiply. So if we come up with this answer, we're going to say, okay, let's see what happens when 0.27, 0.27. Let's see what happens when we multiply and see how accurately close we get. So 500 times 0.27 is roughly about 135. Well, it is 135. 135 times 0.27. is around 36.45, okay? And then 1 times 0.27 is around 9.84. Okay, so we're off a little bit, which is, okay, it's normal. So if you want even better accurate results, instead of 0.27, you can go to the third digit, which was, what was it? We could do 1,4. That might be better. Okay, so this is the actual multiplier. This is the multiplier right here. Okay. Okay, now the question, what was the annual rate of depreciation for the poster? So if this is the multiplier, that means in order for it to have depreciated from something, we should have subtracted something from 100 in order to actually get this number here. So the question is 100, where's the other pen? The question is 100% minus what is going to equal 0.2714, or in this case 27.14%. Sorry, I should do that in percent. 27.14%. So 100% minus what is going to equal 27.14%. And that is your actual depreciation. Because just like in the previous problem on number 54, our decreasing or our depreciation was 20%, but that's not what we multiplied by. We had to take it away from 100. Okay, so if our depreciation, if our multiplier here is 0.27, then that means our depreciation had to be something else. Okay, now it says, write a function that will allow you to calculate how much the poster is worth after X number of years. State the meaning of each part of the equation in the context of the problem. Okay, so the starting value, remember I said, and then the multiplier. So the starting value for your equation here was $500, okay, and what your multiplier was 0.2714x. Okay, so we started with $500 for the poster, and every year you lost a certain amount of money, right? Every year the poster, the band was not popular, more and more and more, and then eventually they just, you know, it only cost $10. So the question is, what percentage of that $500? And then just keep going with that. Write a function, there's a function, you're done. State the meaning of each part of the equation in the context of the problem. That's your starting value. Poster started at 500. 0.274 is going to be your multiplier. Okay, I'm not going to do 62.
Lindsay, Fritz, Sam, Hood, and Monica Cervantes, front office, please. Lindsay, Fritz, Sam, Hood, and Monica Cervantes, front office, please.
Okay, I'm not doing 62 because I think it's pretty self-explanatory, and this video is already at 15 minutes. So if you have any questions, see me.